Okay, here is the start of Chapter 9. This is the Pre-Calc kids. This is the AP Stats chapter. In other words, this is sort of the introduction to what you're going to be learning if, in fact, you're taking AP Stats next year or the year after. So the first couple sections are pretty straightforward. There's stuff that you've seen before, whether it was Algebra 2 or Geometry. Our objective here is to use the multiplication principle of counting, permutations, and combinations. Okay, hopefully you've heard of those things before. If you haven't, hopefully this will jog your memory. So it says, in how many different ways can we order three distinguishable objects? So if I just make those A, B, and C, those are our three objects. Okay, now you don't have to do this for every one, but I'm just going to kind of show you where it comes from. Okay, list out all the combinations. So I can go ABC, ACB, BAC, BCA, CBA, and CAB. Those are all the possible combinations. So the answer is there are 6 different ways. Okay? Now, the way you might think of it as, okay, and if you remember this, that's great. That's the same thing as if I did 3 times 2 times 1. Okay? So, how many choices are there for the first object? 3. How many choices are there for the second object? 2. How many choices are there for the third object? 1. And then you multiply those together. That's the multiplication principle of counting. Okay? Alright, so as you can see here, they talk about the multiplication principle of counting. Okay? Basically, if you have an order of objects or letters or numbers, you just multiply the number of options for each spot. So if you have something, you have a Tennessee license plate, it's shown here consisting of 3 letters of the alphabet followed by 3 numerical digits, 0 through 9. Okay, they want you to find the different number of license plates that could be formed. Okay, now when it says Part A, it says if there is no restriction on the letters or digits that can be used. So that means you can repeat letters and numbers. Okay, well, the first 3 letters, or the first 3 places, are letters. So how many options are there? Well, there's 26 options because there's 26 letters in the alphabet. Times 26 times 26. That accounts for the first 3 letters. Okay? There are 26 choices for the first 3 letters each. Now the 3 numerical digits, and again, we're allowed to repeat here. So from 0 to 9, that's 10 options. Okay? So we're going to multiply all 6 of those together, and we're going to get an astronomical number, 17,576,000 ways. Okay, now if you think about that, in Ohio, that's probably what you're going to see. Actually, there's 4 numbers, I think, but that's a lot of ways. Okay. Now, Part B says if no letter or digit can be repeated. So now once you choose a letter or a number, that letter or number is thrown out, and now you have less choices for the next entry. So you're going to have 26 choices for the first letter, but only 25 for the second, and only 24 for the third. 10 choices for the first number, 9 choices for the second number, 8 choices for the third number. So if I multiply all those together, I get 11,232,000 ways. So obviously that's probably about a third less than if you could repeat. Okay, but that's how you do the multiplication principle. All right, permutations. The big thing with permutations, order matters. Okay? Permutations are all about order. All right? Now, when we talk about that, all right, it says count the number of different 9-letter words, and they say in the parentheses, don't worry about whether they're in the dictionary, that can be formed using the letters in each word. Now, here's the thing you have to worry about. Okay? dragonfly. Now, if you look at the word dragonfly, there are 9 letters. There are 9 different letters. Okay, none of the letters repeat each other. Okay, so what we're going to do is, think about it. 9 options for the first letter, 8 options for the second, 7, and you got to go on down the way. Now, obviously writing this out is a pain in the butt. So, we have an easier way to do it. We're going to write that as 9 exclamation point. Now, if you remember what exclamation point means, that means 9 factorial. Okay? So instead of entering all those numbers in your calculator, here's what you're going to do. You're going to choose the math, you're going to hit the math button on your calculator. You're going to arrow over to where it says probability, and then you're going to pick option 4. That's factorial. So you're going to go 9, math, prob, option 4. Okay? And what you get is 362,880. That's the total number of combinations of dragonfly you can get. Okay? So again, the factorial, that's how to put it in the calculator. Hopefully you have the sound on when you're listening to this. Part B. Now, here's the issue. Okay? In Part A, we didn't have any letters that repeated. In Part B, we do. Okay? We have 2 letters, or we have 1 letter that repeats. Okay? So since T repeats, we have to account for that. So we're going to have 9 factorial like we normally had, but this time we're going to divide by 2 factorial. Okay, now the reason we're going to do that is there's 2 T's, which means basically when you're picking which T goes where, there's 2 of them, so it doesn't really matter. So anytime you have a repeating letter or a repeating number, okay, do your total number of permutations on top, 9 factorial, okay? But you have to divide out by the number of, or the letter that repeats that number of times. So the T repeats twice, that's why it's 2 factorial. If the T showed up 3 times, you do 3 factorial. So in your calculator, you could do 9 factorial divided by 2 factorial, and you get 181,440. Okay? And again, remember, this is the sequence of buttons you need to do for factorial in your calculator. Okay, Part C. Now, Part C. Now, look at what repeats in Part C. You have 3 E's and 3 B's. So, what does that mean? Well, that means we're going to have our 9 factorial. Except this time, okay, we're going to divide. There's 3 E's, so we have to divide by 3 factorial. Okay? However, there's another 3 B's, so I'm going to have to multiply by 3 factorial on the bottom. So in your calculator, you're going to do 9 factorial divided by, parentheses, 3 factorial times 3 factorial. And that gives you 10,080. Okay? That's a bad 0. Alright? So just understand, when you have a letter or number that repeats, you have to put that on the bottom as many times as it shows up. So in Part B, T showed up twice. So we had 2 factorial on the bottom, and that was it, because T was the only number that, or letter that repeated. In C, we had 2 letters that showed up 3 times, so we have to account for that in the bottom. Okay, now this is the formula for n objects taken R at a time. In this problem here, we were choosing every single letter. Okay, we had 9 letters, we chose 9 letters. Okay, here, if we had 9 letters, maybe we only chose 5. Okay, and the order of those letters mattered. So that's the formula. But what you're going to do, okay, what you're really going to do here is you're going to hit the math button. Then you're going to do, again, you're going to do the probability option. You're going to arrow over to that. And then you're going to choose option 2, which says NPR. Okay? So in your calculator, you can easily I know this says without, but we are doing it with the calculator. Okay, so you need to practice that. Evaluate each expression with the calculator. So 6, now what that means is I have 6 objects, I'm choosing 4 of the 6, and the order of those 4 matter. Okay, so when you plug that in your calculator, you should get 360. For B, you should get, that's 11, choose 3, so there's my washer. Now for C, okay, you can't plug N in to the calculator, okay? So what you have to do here is you have to use your multiplication principle, okay? What does that mean? Well, you have N objects, and you're choosing 3 of them, okay? So how many choices do you have for your first object? N. How many choices do you have for your second object? Well, you have 1 less than you had before, so that's N minus 1. Okay, well, how many choices do you have for your third object? Well, you have 2 less than you had before because you chose the first one, chose the second one, now you have 2 less. And that's your answer. Okay, you have to use the multiplication principle in that situation. If they're both numbers, you just plug it in your calculator, but this is sort of a special case. Okay. Okay, you've got 16 actors answering a casting call to try out for roles as dwarfs in a production of Snow White and the Seven Dwarfs. In how many different ways can the director cast the 7 roles? Okay, so obviously order does matter, okay, because you can't, you have to pick Sleepy Dwarf, and then once Sleepy Dwarf's gone, you can't choose him anymore, okay? So what we're going to do is we're going to have we have 16 actors, the order matters, and we're only choosing 7 actors. Okay, 7 people got it, obviously for the 7 dwarfs. So in your calculator you do 16p7 and you get 5,765,600 ways, which is insane. That is an insane number of ways you could get 7 roles out of 16 actors. Now, combinations, here's the thing about combinations, okay? Combinations, order does not matter, okay? Doesn't matter. So, again, you can use NCR now in your calculator, all right? So, what you're going to do is, you're going to, in this case, when you use your calculator, math button, and then arrow to prob, and then this time you're going to choose option 3 to get NCR. Okay? Now, in example 6, it says in each of the following scenarios, we need to determine if permutations or combinations are being described. So part A says a president, vice president, and secretary are chosen from a 25-member garden club. Order matters. Okay, order absolutely matters. A cook chooses 5 potatoes from a bag of 12. Well, does it matter which potatoes he picks? No. So that's combinations. Teacher makes a seating chart for 22 students in a classroom with 30 desks. When I make my seating charts, order matters. Okay, the order of the students sitting matters. So that's permutations. Now that's all you had to do there, was just determine which one you had to use. Okay, in the Miss America pageant, 51 contestants must be narrowed down to 10 finalists who will compete on national television, and how many possible ways can the 10 finalists be selected? Now here's the thing. At this point of the competition, okay, they're not picking first, second, and third place, or the runner-up in first place, however those things work. They just want to, out of the 51 contestants, get 10. Okay, does it matter what order they're in? Does it matter if Miss USA is first or Miss Ohio is first? No, it doesn't matter. She could be 10th. She could be first. It doesn't matter. There's just going to be 10 finalists. So what we're going to do is we have 51 contestants. By the way, there's 51 because Puerto Rico, I believe, is the 51st. Whoops, why did you use P? You just said the whole thing about C. There you go. Okay, so 51, NCR 10. Okay, by the way, with the newer calculators, with the TI-84s, choose the NPR, NCR first, and it'll let you plug the numbers in after. If you have the TI-83, put the first number in, then choose your NPR, NCR, and then put in your second number. Okay? So there's a difference between the two calculators. Now, when you put that in your calculator, this is what you're going to see. You're going to see 1.2777. You see if I have this right. I figured this out. So this is what you're going to see in your calculator. Okay? Now, here's what that means. That means that you move the decimal point 10 to the right because it says E10. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got to add 2 zeros there. So here's my number. Oh dear. Make sure those are all right. Okay, so now we got to put commas in. So I just start from the right, and every 3 numbers put a comma. So, whoa. That is 12,777,718,700 different ways out of the 51 contestants that you could narrow it down to 10. I'm glad I'm not a judge. Next! All right, now here you go. The Georgia Lotto. Now this is good. If your parents or you are lottery people, here you go. The Georgia Lotto requires winners to pick 6 integers between 1 and 46. The order in which you select them does not matter. Indeed, the lottery tickets are always printed with the numbers in ascending order. How many different lottery tickets are possible? Okay, well, you've got 46 numbers. The order of those numbers don't matter, okay? Now, when they say the lottery tickets are always printed with the numbers in ascending order, yes, on the ticket they're in ascending order. But when they actually pick them at 7:30 on Wednesday night or whatever, okay, and those ping pong balls come out of the hopper, those numbers aren't in order, okay? They're just random order. So that's where combinations come into play. So when you do 46C6, you get 9,366,819 different tickets. Now think about that. I don't even think there's 9,366,000 people that live in Ohio. Okay? So there's more tickets, and I know this is Georgia, but just for the sake of argument, it's the same thing for the Ohio lottery here, for the lotto. There's more tickets than there are people. So your chances of winning are not good. Okay, last one. I know this video ran long, but want to make sure everybody's on the same page. Armando's Pizzeria offers patrons any combination of up to 10 different toppings. And they list the 10 toppings. How many different pizzas can be ordered if we can choose any 3 toppings? Now, does it matter what order you pick the toppings in? Of course not. Who cares? So you put the sausage on first. So what? You can put it on second. You can put it on third. Doesn't matter. So we have 10 toppings, choosing 3 of those toppings. So if I do that, there's 120 different pizzas that I can order. Okay? Now, part B is a little bit different. It says how many pizzas can be ordered if we can choose any number of toppings, 0 through 10. Okay? So whether you want it plain or whether you want everything on it or anything in between, how many of those pizzas can be ordered? Okay? So we could do this, okay? But, and I'm saying N here because they don't tell me how many specifically to choose. They're telling me it could be anywhere from 0 to 10, okay? That's too hard. Let's make this easy. Okay, let's make each topping a yes or no decision. So in other words, for each topping, I'm going to ask yes or no. Okay, so think about it. How many options are there for pepperoni? Well, there's only 2. It's yes or no. Mushroom, yes or no. Sausage, yes or no, and so on. Well, that's 2 choices per topping. So that's 2 times 2 times 2 times 2 times 2. Oh boy, times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you multiply that, that's 1,024. Now, really, what that is, what you really found, is the number of possible pizzas, period, regardless of how many toppings. Okay? So that's sort of a special case. I would say that this one is the one you're going to see the most. All right? Oh my God, we passed 20 minutes. Sorry. Yeah. The good news is hopefully you'll be doing this in class, so it won't be that bad. Sorry.